Hello there, Himanshu Pareek this side. I'm a physics faculty here at askIITians, and today I am going to teach you the chapter Motion in One Dimension, the lecture number 3. So, as you have already learned the lecture number 1 and lecture number 2 of Motion in One Dimension. So, I hope you have got the idea about speed, velocity, acceleration, and then apart from this, we have also seen how to use the differentiation in the calculation of speed and velocities. So when we'll talk about the instantaneous velocity and acceleration, then we need the help of differentiation. Now, in this particular session, we are going to deal with the equations of motion. Now, what is equation of motion? So basically, it is similar to that which you have already done in mathematics. Like suppose if I give you one expression, let's say if I give you y is equal to x plus 2. Now, if someone tells you that if x is equal to 1, what is the value of y? You can easily find out that y is equal to 1 plus 2, which is equal to 3. So finding the values of y becomes easy once you know the value of x. Now, similarly, in today's session, what we are going to do, we are going to deal with equations of motion. That when particle moves, suppose if somebody gives you the initial velocity with which a bike starts the motion, all right, and then if somebody gives you the value of acceleration also, and then if you have to find out the value of velocity of the body after a time t. So let's say here we have an example. Suppose if you start from here with the initial velocity 10 kilometers per hour, then what will be your velocity at this instant if the acceleration is present as 2 meters per second square? So how to deal with such type of questions, that you will be learning in today's session. Okay. Now, first of all, we have the distance time graph. We'll talk about it. Then velocity time graph, though already we have got the idea. So I hope this is just a revision class for the first 10 minutes, and then we will come to the equations of motion. If you haven't seen the distance time graphs and all, first I would recommend you to go to the graphs, the lecture number 2, right, where we have discussed about the graphs, and then we'll talk about the equations of motion. Okay. So let us start our session, distance time graph. Okay, so distance time graph. If the distance time graph is shown in the example number 1 here, if the body is having a distance time graph like this, means as time passes, the distance is not changing. Means the body is at rest. Example, a car parked, right, in a parking. So that time the distance is not changing. It is at rest only. Then uniform motion, if you remember, then uniform motion is the equal distances covered in equal intervals of time, right? So if you take a simple interval of a certain time interval, suppose I have taken this time interval, and now if you see the distance covered by the body, then you will find that this is the distance covered by the body, this much. Okay. And then if you take some other time interval, suppose if somebody takes a time interval this of same size, let's say this time interval was of 1 second, then you should take this also as of 1 second. And now if you see the distance covered by the body in the 1 second, you will find that this distance and that distance, I mean this one is d1 and this one is d2. So this would be d1 equal to d2 for a uniform motion, because in equal time intervals, body covers the equal distances. So that is what the meaning of uniform motion. So for that, the graph would be a linear graph. It would be a straight line graph. I hope you got my point. All right. So basically, that's what the meaning of a uniform motion. Now, for a non-uniform motion, this graph would not be a linear. It would be some curve actually. Okay. So now when it is a curve, then we will get unequal distances in equal intervals of time. Suppose you take this interval, then this is the distance covered, this much, right? You have to look up for the y-axis. Suppose if somebody takes this time interval, just a second. Suppose if somebody takes this time interval here and here. Now see, this interval is of 1 second This interval is also 1 second. But if you compare the distances covered by the body, then there is a quite gap here in this case. So distance covered by the body is little bit more now. So it is not, if this is d1, this is d2, then d1 is not equal to d2 now. That's what the meaning of non-uniform motion. So that is what basically distance time graph represents. Now velocity time graph. So first of all, you have learnt in the previous lecture that velocity time graph, if I give you, then if you calculate the slope of velocity time graph, which will be dv by dt, differentiation of velocity with respect to time, it tells you that the small change in velocity divided by small change in time. dv represents the small change in velocity. dt means the very small time interval. So this would give you the acceleration. Got my point? So that's what represents the acceleration. So slope of velocity time graph gives you the acceleration. So here you can see the velocity time graph is like this. This is the velocity on y-axis, the time on x-axis. So if you first talk about this blue color line, then this is the slope, which is the tan theta. So that's what would represent the acceleration. Okay, slope of velocity time graph. Now here you can see the speed is constant. So slope is 0 here. There is no inclination with respect to x-axis. Here we can see for the green color behavior, which I have made now blue. Let me make it again green. So for this green color graph, the velocity is decreasing. So that's a deceleration, right? Retardation case basically. And then we talk about here. So as we applied in the previous case, if the distance time graph is a linear, it is a uniform motion, means the uniform velocity. Similarly, if velocity time graph is linear, means it's a uniform acceleration. In equal intervals of time, by equal amount, velocity would be changing. But for non-linear graphs, like in the example here, so here if you take equal intervals of time, suppose if you take this interval of time, then velocity would be changing by this much amount. But if somebody takes the interval here of the same size, suppose this interval is of certain size, this interval is of certain size, then both the intervals of same size, let's say 2 seconds. This increment is slight and this increment is very high. Okay, so for non-uniform accelerations, the graph would be non-linear, and for uniform accelerations, the graph would be linear. It's exactly similar to the previous discussion. For uniform motion, the graph is linear between position time, distance time, and the graph would be non-linear if the non-uniform motion is happening, means the speed is changing with respect to time. Now we can start our equations of motion by graphical methods. So first of all, you can see the first equation of motion. This is the first equation of motion. Let us derive it. It's very simple to derive. You just need to know that the slope of velocity time graph gives you velocity acceleration. Slope of velocity time graph gives you acceleration, as we have said before, dv by dt. Okay. Now what is v here? V is the, let's say at t equal to 0, the velocity is u. So u is the velocity at initial velocity, t equal to 0. A is the acceleration. I am writing the short form, ACC. V is the velocity after time t, or you can call it a final velocity. So here we can see this is the graph, this green color line, that's the graph. Let us calculate the slope of this graph. So to calculate the slope of this graph, I can simply calculate the tan theta, because tan theta is what represents the slope. So if this angle is theta, I can say tan theta is the slope, and tan theta is the slope means the slope of velocity time graph gives you what? Acceleration. Do not get confused with the shaded area here, the blue and the red color. Don't get confused. It's a very simple thing. All right. So we will talk about it very soon. It will be used in the next equations of motion. So tan theta is equal to acceleration. Why I'm calling it? Because the slope of the graph of velocity time is representing the acceleration, and slope is also represented by tan theta. So if I come to that part, then tan theta would be equal to what? This height, because tan theta is equal to perpendicular over base. Yes or no? If you look at this triangle, ACB triangle, then tan theta is equal to perpendicular over base. What is base? This much length. That's a t. Total time is t. This coordinate is t here. It's not x. It's a time axis, right? That is just shown y and x. So y axis pe we have taken velocity, on horizontal axis we have taken time. Now, if you see one thing clear here, then what is the base? Base is t. What about perpendicular, the BC? So this total length is v, because that's the coordinate v. This coordinate is u. This length is u. So what about this remaining one? That will be v minus u. So tan theta equal to v minus u over t, and which is also equal to acceleration, tan theta. So v minus u is equal to at, hence v is equal to u plus at, which we call the equations of motion first. Simple, just calculate the slope and you'll get the answer. Similarly, if you go for the second equations of motion, so as I talked about the velocity time graph here, so slope of velocity time graph gives you the acceleration. But if you do the opposite thing, if you calculate the up area of the velocity time graph, it will give you the displacement, right? So if you calculate the area of the velocity time graph, it will give you the displacement. So suppose if I make a small velocity time graph here, going this way, if you calculate the area under this graph from here to here, let's say, this area would be giving you the displacement covered by the body from T1 to T2, right? That's the meaning of area under the velocity time graph. It always gives you the displacement. Okay. Now, why it is giving you displacement? Easily you can predict it. See, if you take this vertical height, that would be representing velocity. If you take the horizontal length, it would be representing the time. So velocity multiplied time is nothing but the displacement. Just like velocity is displacement over time. So if you take time in the multiplication with the velocity, Vt is equal to displacement. So that's why when you calculate the small area, if you take a small area here, very small area, all right, if this time is certain interval and this is the velocity v, you can say when you calculate this area, it's like a rectangle whose this length is time and this length is v. So when you calculate the area of this rectangle, you will get velocity into time, which would give you the displacement. All right. So area of this rectangle basically. Similarly, we can have a different graph possibilities. Suppose if I talk about again this behavior, velocity changing from u to v, final velocity is v here, as you can see here on the board, and this is u here. If you calculate the area under this graph, so what is the area under this graph? This entire thing. This entire thing is the area under the graph. Now I can divide this area into two parts, guys. One is this area, the red color part. This one. And other is this area, which I'm showing with the green color. As we have done in the previous part also, this is v minus u and this is t. Now simply I can say the total area will be equal to area of the triangle plus area of the rectangle, the green color part. Let us talk about the area of a triangle. Half base is time, t. Height is v minus u plus area of the rectangle. So this length is u only. We have discussed this in the previous part also. This is length is v only. Okay. This length multiplied width. This is t, this is u. So ut. So what you will be getting? Now here, this total area will be giving you the displacement from 0 to t. Right? That's what we have learned. Area under the velocity time graph gives you displacement, and velocity time graph slope gives you acceleration. Always remember this. You can make it as a short note. Now what I can do here, From the first equation of motion, I can write this v as u plus at. U and u term will get cancelled out. So you will get half at square plus ut. That's the total displacement. So that's how we get the second equation of motion. Simply calculate the area under the curve. How you can remember it? First equation of motion involves the velocity and acceleration. So calculate slope of velocity time graph. Second equation of motion involves displacement and time. So calculate area under the curve. This everything is coming from that basic rule. Area under the velocity time graph gives you displacement. Slope of the velocity time graph gives you acceleration. Going ahead, third equation of motion. Third equation of motion is quite similar. The same way to calculate the first and second equation of motion. What we can do here, see. Again, you calculate the area under the graph. This entire thing. Now, I don't think this is very quite new to you. So I can simply write it as, we have done this in the previous section also, right? In the second equation of motion derivation. We can write down this area as area of the triangle, which is half multiplied v minus u multiplied time plus ut, area of the rectangle. We have done this in the previous section. So you should watch that if you haven't understood it. Now, we have to calculate the relation between velocity and displacement. So what you should do, you should replace the time here. So first of all, look at me what I'm doing. I am taking the time common. What this will become? V minus u over half plus u, which I can write as v by 2 minus u by 2 plus u multiplied time. U minus u by 2 is nothing but u by 2. So this will become u plus v over half multiplied time. Now you recall the equation number 1, which says v is equal to u plus at. I can write this as v minus u is equal to at. So I can also say that v minus u over a is equal to t. Just divide both sides with a. Now this value of t I am going to use here. So when I replace it here, what I'll be getting? U plus v by 2 multiplied v minus u by 2. Oh, sorry, a. Now this is a plus b multiplied a minus b. You should know this identity from mathematics. A plus b multiplied a minus b. It is nothing but a squared minus b squared. So displacement is equal to what? This will become v square minus u square divided by 2a. Now you cross multiply this 2a, or you can say both sides multiply with 2a. So when you cross multiply this 2a, what you will be getting? 2as is equal to v square minus u square. Now you just place them properly. You can write down that when you take this u square term on the left hand side, what you will be getting? V square equal to u square plus 2as, which is the third equation of motion. So first equation of motion connects velocity with respect to time, right? If acceleration is constant, yeah, you should remember that. In all the three cases, I have taken acceleration constant. Why I'm saying this? Because when acceleration is constant, then only the graph behavior is linear. If you don't get the acceleration constant, the graph would be of something like this. And for such graphs, it requires a little bit higher mathematics to calculate the area under the curve. Because now you won't be able to apply simply the area of a triangle. Here, this would be, you would be getting some different kind of curve, whose area we don't remember from maths. So this will be solved with the help of integration. So for constant acceleration, we have derived them. Why constant acceleration? Because for constant acceleration, only the velocity time graph is linear, because it's a uniform motion, uniform velocity changes. Right? Exactly. Now I am going with the equations. One question. So a race car accelerates uniformly from 18.5 to 46.1 in 2.47 seconds. Calculate the acceleration of the car and the distance traveled. Very simple. to calculate the acceleration of the car. That's the initial velocity. This is the final velocity, and that is the total time taken to calculate. What you should do, write down first equation of motion. Don't go for second one, because second one and third one we'll use when displacement interest will be there. Right now our interest is not in calculating displacement. So final velocity is 46.1. This is 18.5. Acceleration we have to calculate. Time is 2.47. You can take this on the left hand side. So this will become what? So now you just have to subtract it. 46.1 minus 18.5 is equal to 2.47 multiplied A. So what this will become? This will become 26.1 plus 1.5, which is 27.7. I hope I'm doing the correct calculations. Right? So recheck it if I have made anything wrong here. I hope it's correct. Yeah. So 20, 26.1, 26.1, it's 27.6. All right. Yeah. Okay. Divided by 2.47, that's the value of acceleration. These calculations are a bit tough, so I'm not doing further. Right? In the exams, you get a very simple calculations. Suppose if you want to find out the distance covered, then you just have to write down S is equal to UT plus half AT square. So you have calculated the acceleration now. That's why I'm writing this. Okay. So initial velocity is 18.5. Time taken is 2.47 plus half acceleration is this value 27.6 divided by 2.47 multiplied time squared, which is 2.47 whole square. Now we just have to solve this equation and we'll get the answer for displacement. So it's that simple. If it would have been a case of retardation, I would have written a negative sign here. Right? So that's how we solve the question. So I'd always identify whether it is a velocity time or acceleration time, which relation you are interested in, and accordingly you go for the equations. Now we will derive the same equations with the help of algebraic method without using any graphs. What I should say, that acceleration is equal to change in velocity upon time. I'm assuming that acceleration is constant. I'm assuming that acceleration is constant. Now what I can say, that delta V is nothing but what? Final velocity minus initial velocity, V minus U. V is the final velocity. We are using the same symbols as the previous case. Divided by time taken T to change the velocity. So A is equal to V minus U. Do the cross multiplication. You will get AT equal to V minus U. So V is equal to U plus AT. That's it. So it's very easy to derive this first equation of motion. Just write down the definition of acceleration. The change in velocity per unit time. That's the definition of acceleration. Now, second equation of motion, we can also do with the same way. So now for second equation of motion, what you have to do? So first of all, you should realize here that we have to make use of what? Some displacement terms over here. So when we'll make the use of some displacement terms over here, right, then we should be using some equations where the displacement is coming. So what I can say here, suppose if the body is having initial velocity u and final velocity is v. So what will be the average velocity of the body? AVG, average velocity. For a uniform acceleration, I mean when acceleration is constant, in that case I can write it as u plus v by 2. That's the average velocity. I know that this is equal to displacement upon time. Yeah, velocity is equal to total displacement upon total time. So now what I should say, that S is nothing but equal to the cross multiplication of time, u plus v over 2 multiplied time. Yeah. So this is the same thing I will do for equation of motion third also. This is a common thing, right? So average velocity, right? And then write down the total displacement upon total time. And then you multiply the time on the left hand side. You will get the displacement as u plus v by 2 over 2, u plus v by 2 multiplied time. Now, here comes the difference. When you derive the second equation of motion, you are not interested in knowing the velocity, final velocity. So that time we should replace. So how we will replace it? U plus at. This is what I did in the graphical method also. In the derivation of second equation of motion, we use the first equation of motion. So this will become 2u plus at divide by t multiplied time. Now I can do one thing. I can take them separately in the denominator of 2. So this 2u by 2, it will remain only u, and this is at by 2. Now I'm going to multiply this t inside. So what you will be getting? Ut plus half at square. I hope you have got my point. Okay, so that's a ut plus half at square. Right? Simple. Write down average velocity, then replace velocity from there. Final velocity. That's it. Now I'll start from here only. U plus v by 2 is into t. That's the total displacement for derivation of third equation of motion. So what you will be doing here, you will be writing total displacement as u plus v over 2 multiplied time. Now you do not want to keep time in the third equation of motion. There is no time term. So what I'll do, v equal to u plus at. I can write v minus u equal to at. Same thing I did in the previous method also. I calculated the value of time by doing the cross multiplication or dividing both sides with a. This value I'm going to put here. And now you know what to do. We have to use that identity. U plus v over 2 and v minus u over 2. I have replaced the time with v minus u over a. Do the cross multiplication of these things. You will get 2as. And this is a plus b multiplied a minus b. So v minus u multiplied v plus u. You'll be getting this as v square minus u square, which would become v square equal to u square plus 2as. That's it. That's the third equation of motion. So all the three equations of motion we have derived with both the methods. Either it is a graphical method or it is a algebraic method. Let us just recall what we have done. So first of all, we calculated the graphical method. In the graphical method, to derive the first equation of motion, use velocity time graph slope. Tan theta, you'll get the answer. That is equal to acceleration. Second equation of motion derivation, find out the area under the curve. Right? And from there, you have to remove the final velocity term because v minus u will be coming there. Let us just go back for a second. Yeah. V minus u is coming. So just replace v from the first equation of motion. You'll get the second equation. Third equation of motion, again calculate the area under the curve, but now don't replace v. Instead, replace time. Similarly, for algebraic method, use the definition of velocity. For second equation of motion, write down average velocity and then replace velocity from there, which we have done in the algebraic graphical method also. Final velocity as u plus at. Third equation of motion, replace time. That's it. Because you don't want time term to be there in the third equation of motion. So now we have three equations of motion. If you see them all together, v is equal to u plus at, s equal to ut plus half at square, and v square equal to u square plus 2as. When we see all these three equations together, then you should remember them like this. If you need velocity time graph, velocity time relation, if the question is talking about the final velocity and the time, go to equation number 1. If the question is talking about displacement and time, go to equation number 2. If question is talking about velocity and displacement, final velocity and total displacement, go to equation number 3. That's how you should identify which equation to apply in which question. Let us try this question. A car starts from rest and accelerates uniformly over a time of 5.21 seconds for a distance of 110 meter. So total time is given to us. All right. Total time is given as 5.21 second. Total displacement is given as 110 meters. We have to calculate the acceleration of the car. Think about it. What to use? Yeah, initial velocity is also given 0. It starts from rest. Pause the video here and think about it. Which equation to use? Displacement time relation given. Not the first one because it does not involve displacement. Not the third one because it does not involve time. Use second equation of motion. When we will use this, put S as 110. Initial velocity is 0, so this term will be 0. Acceleration we have to calculate. Time squared, so 5.21 squared. Now acceleration is equal to what? 220 divided by 5.21 whole square. Meters per second square. That's the unit of acceleration. Right? So that's how we will be applying these equations of motion. Right? So always just remember this thumb rule that velocity time relation, first equation of motion. Displacement time relation, second equation of motion. Velocity displacement relation, third equation of motion. And that's it. So we have derived all three equations of motion by both the methods. I hope you have understood this, right? If you have any question, if you have any confusion about them, if you get stuck in any question, just put your queries on the batch discussion forum PDF and you will get the answer there. Got my point? Okay, then that's all for today. So that's all from my side. Thank you so much, guys. Bye bye. Thanks for listening.